Hello, I'm Jonathan Moussa, a software scientist at the Molecular Sciences Software Institute, hosted at Virginia Tech. I talk about the future of MOPAC as open source software and also to lead this meeting. So just the high level view. So MOPAC is now hosted on GitHub, which is kind of a center of the open source software world, which hosts, I think, a significant fraction of all the open source software projects in the world. And the support for MOPAC as open source software is being provided by the Molecular Sciences Software Institute, which is funded by the U.S. National Science Foundation to support various software development activities in open source software for computational chemistry and material science. So before I say anything else, I'd like to welcome everyone to this meeting. There's 11 invited speakers, and I try to invite people to capture a representative selection of various MOPAC activity over the last decade. People have contributed development of new features to MOPAC, other popular pieces of software that interface with MOPAC, and some application work. And there are about 68 registered participants to the meeting, and a rough breakdown of where they're coming from. It's mostly from academia, mostly students, mostly US based, and the majority are MOPAC users or have used MOPAC, but surprisingly there is a significant fraction of people who have not used MOPAC but are curious enough to attend this meeting to learn more about it. Okay, so a brief history of MOPAC. So the central theoretical developments that led to the software come from the mid to late 70s. So this was from a time when computers were much less powerful than they are today. And there was an interest in building simplified models. So these were Hartree-Fock level calculations in a minimal atomic orbital basis. And such things aren't accurate enough to describe experiments. So the matrix elements and integrals involved were reparameterized to try to match as much experimental information as possible. And MINDO3 was an early model, and MNDO was kind of the foundation for all of this future development in MOPAC. So this work happened in the group of Michael Dewar at UT Austin, and all the founding theory and model work was from Professor Walter Thiel, and Jimmy Stewart was the one responsible for putting this all together into very user-friendly software and putting together all the machinery to successfully fit these models. The pinnacle of the model development being, in those early days, the AM1 model. So that has, as of recently, about 17,000 citations. And as of, from a Nature magazine survey from, I think, 2014, it's the 80th most cited paper in all of science. So that's a pretty high pinnacle to reach. The first release of MOPAC was in 1983. So this year is a 40th anniversary of the first release of MOPAC. So that's a nice milestone to reach. So it was released on the Quantum Chemistry Program Exchange, which was a system at the time of distributing software over postal mail before things like the internet and email and file transfer existed. And on that exchange, MOPAC would come to be the most popular piece of software. Eventually, MOPAC transitioned into a more commercial existence and was acquired by Fujitsu. And it still maintained open distribution to academics through the QCPE, but it was sold for non-academic users. Eventually, Jimmy Stewart started his own small company and released MOPAC through Stewart Computational Chemistry. And now it's being released back into the public domain as Jimmy's preparing to retire and wants to see MOPAC persist and thrive while he can relax and go fishing or something. So why is MOPAC so popular? Now, I think there's just a simple reason for this, that there is a lot of demand for atomistic simulation software and quantum mechanical software, but that demand is very cost sensitive. As the computational cost gets higher, and as the difficulty in using software gets higher, the demand is going to sharply drop off. And semi-empirical software is kind of in a sweet spot where it's cheaper than quantum mechanical codes. And it's easier to use in a lot of novel applications than force fields when you don't know if a parameterization is going to be effective for the system you're studying. And here's a picture from one of those, from a workshop held by QCPE, which regularly held workshops, and Jimmy was regularly in attendance, given that he was associated with its most popular software. So another aspect of MOPAC because it's so popular, or it's popular, is also attributed to the fact that it's very accessible. So anyone who's downloaded MOPAC has probably seen the distribution page on openmopac.net. And in transitioning to open source, that mode of distribution has been maintained. So it's long made binaries on Mac, Linux, and Windows directly available to users, so people don't have to compile it themselves, which is itself a barrier for a lot of people. And that is now synchronized with releases on GitHub. And also, I'm trying to expand distribution, and for example, it's now available on the Conda package manager. So now you can get Conda by just one line on your command line if you have the Conda package manager installed. The other aspect of accessibility is that it's relatively easy to use in its most basic modes of operation. You put a molecule together, and some file formats are very directly compatible with MOPAC. You can take an XYZ file, you can add a single keyword line at the top, and it can even be blank because MOPAC has defaults for everything other than the geometry. And you can then run it and get some output that might be useful to you. It'll relax the molecule and tell you about its heat of formation and other properties. And it's also relatively inexpensive. For hundreds of atoms, you can relax a molecule in a few minutes. For thousands of atoms, you can complete SCF cycles in a matter of minutes with the Moussa fast solver. And in moving to open source, MOPAC's also making other things more accessible as well, including the param software for parameterizing new models and all of the reference data that has been used in recent model parameterizations. So to try to capture the activity and impact of MOPAC, I think the best representation is its footprint in the scientific literature. So here is a time series of, from when it was first released to the modern day. And it rapidly grew in popularity, and it's maintained a high level of use and citation for a very long time. And now it kind of peaked in the mid-90s. And I mean, I don't necessarily know the precise explanation for that, but I think a reason is likely the rising popularity of density functional theory. So B3-LIP and PBE, the two most popular functionals, were developed around that time. And while MOPAC is associated with the 80th most cited paper in all of science, B3-LIP is associated with the 7th and 8th most cited papers in all of science, and PBE is associated with the 16th most cited paper in all of science. So it has a very strong competition. There's about 5,000 unique visitors to the main website per month and about 3,000 downloads per month. So it still maintains a healthy level of activity. And how it compares to other codes. So this is a summary from atomistic.software, which is a nice database of popular atomistic simulation codes and their usage. And this is the top 20 codes by citation in literature. And it would not surprise anyone that Gaussian and VASP are at the top. And then GROMACS and LAMPS are the two most popular codes. And MOPAC does make that top 20 list and is the most popular semi-empirical code. So it still competes pretty well to this day. So why are we having this meeting? So there's an aspect of advertisement and promotion, just to get the word out about MOPAC for people who are not familiar with it. Also an element of celebration. I wanted to celebrate the many successful years that MOPAC and Jimmy Stewart have had. And we're having some discussion sections in this meeting to try to gather feedback to guide future development, to see what people would like. Both other developers, users, anyone is free to share their opinions. And also to try to foster a sense of community, which can be difficult. MOPAC has a lot of users, but just having a lot of users doesn't mean there's a coherent and cohesive community. That takes a bit more. That takes overlapping activity, enough activity so that people interact and have a need to communicate. And that hasn't necessarily happened, especially among developers. It's kind of a a high weight social network where most of the development has run through one person, Jimmy Stewart. And so to have a community, there kind of needs to be interactions among other people, not necessarily running through a central node. So as an open source effort on GitHub, the barrier to interaction is as low as it's ever been. So I'm still maintaining email-based support. So there's been the mrmopac@attnt.net email for the longest time. That's Jimmy Stewart's personal email. It's not going away anytime soon, but it's no longer the central support email for MOPAC. So I've taken over support responsibilities. And that still maintains a certain level of activity, but also people can interact now through GitHub itself. So there's an issues board for people to report bugs and maybe request certain well-specified features. And then there's a discussion area for more open-ended types of discussions. And there's been a decent amount of activity there, but maybe not as much as I'd like. There's certainly room for there being more activity. So the core development, just kind of a high-level summary. Oops. Yeah, so the under the hood development that has allowed MOPAC to make this transition to open source. Most people are not going to see this and probably not very interested in it, but if you want to compile it yourself, there's now a CMake-based system for building and testing. The deployment, every time there's a release, that's now automated mostly through GitHub Actions. So it doesn't take much for me to just push out a new release when the time comes. There's now this distribution through the Conda package manager and the Conda Forge channel. And there's been a lot to make MOPAC more portable. It can compile under any popular compiler now. And I've made some performance improvements along the way as well. And the source code and reference data have been organized to make it more approachable and accessible to other developers, hopefully. So more public-facing things that continue to be in development, and something I'd like to get user feedback from potentially, are new interfaces that are still in development. So there's an API that was contributed recently in an open pull request, and I'm still trying to integrate that into the main body of the code. There's another MOLSI project, the MDI, the MOLSI driver interface that I'm trying to integrate with MOPAC. And also there is an experimental unreleased Python interface that connects up with these things. And also I'm migrating the website. openmopac.net is not something that really can be maintained long-term by an open source community. So that needs to transition to something based on Sphinx that's easy to maintain and contribute to. So that is a work in progress. And then there's just various ongoing activities. I try to be responsive to bug reports and fix them as soon as possible. GPU support is not presently enabled in the open source version, and that's something that needs to be addressed at some point. Decisions need to be made whether to actually do it or maybe decide not to do it. That remains a bit unclear. And there may be some new models in the works, though there's no definitive plans for their release yet. So then here's a brief snapshot of what the new website looks like. So this is something I started about 2 summers ago, but then realized how much work would be involved in putting the whole thing together. So I kind of put that on hold, but the time is coming soon for me to come back and wrap that up and put all the content there so that we can really make a transition to this new website. But it is publicly available if you want to browse it. The keywords, about 20% of the keywords have been migrated so far. So then another side of open source development is, of course, contributing. And contributing is also easier than ever. You can grab the source, you can compile it yourself, and you can submit changes through the pull request system on GitHub. And there's some open pull requests on features that I'm still trying to integrate. And there's many successfully completed pull requests, and one will be represented at this meeting, one by Brent Westbrook, who contributed a feature over the course of his research that he'll be talking about. And so actually to pull from GitHub and compile MOPAC yourself, if everything is set up properly, it's less than a dozen commands on the command line. You use git to make a copy, you make a directory to build it because it's out of source building with CMake. You call CMake, it sets up a make file, you call make, and then MOPAC is there to be run. So it takes work to get it to that point, but with so I'm running out of time, but I'm near the end now, so not trying to respect time. Okay, so then briefly now, just about the future. So an important aspect of open source development is we need to balance, people contributing need to balance what they put in and what they get out. That's essential for sustainability. Otherwise, things are just going to die off. You're going to put in too much, not get enough out.
Jonathan, we've lost your voice.
Yeah, sorry, I think I just disconnected.
You're back.
Yeah, sorry about that. I think maybe Zoom is reminding me to wrap up. Sorry. Okay, yeah, so let me wrap up. Yeah, so yeah, I'm interested in development happen, but other people can step in and contribute major new features, you know, both from academia and other commercial interests. Like as an open source project, that's always a possibility. And it would be nice if there was a growing sense of shared responsibility. There's a lot of codes that connect up with MOPAC, and you know, as an open source effort, it's kind of a common ground now, and all of them are free to, you know, make their interests known and you know, help that that shared burden. All right, and with that, I'm going to wrap up my talk. So this is going to go like any normal workshop where you know, we're going to be listening to talks, and between talks there'll be time for questions, and we'll try to run that through people raising their hands in Zoom and calling on people. Let's see if I have to stop sharing my screen to see that. Yeah. Okay, yeah, so if anyone has questions, please raise your hand and I'll try to call on people. And I probably should wrap this up. I probably don't have too many questions for myself, or probably don't have too much time for questions for myself right now, because I'm running into Jimmy's time slot. So you know, if you have questions for me, feel free to bring them up during the discussion section that we'll have. I think we'll next week. So